So you probably know I've been working, some of the stuff I've been working on, right? I've been writing the grey paper, working on Jam, doing a bit of coding in that direction. But actually, as it happens, for the past fairly substantial, I don't know, 2 years, let's say, period of time, been thinking about one of the very linchpin problems in this space. In essence, Sybil resistance, right? It pops up everywhere. Blockchain systems are based on game theory, and oftentimes the way that we reason about games is that we need to limit the number of players or manage the fact that they can be arbitrary in plurality. And this is this falls into a sort of fairly general problem set, which is largely characterized as Sybil resistance. Sometimes we really want to know when we're designing digital systems that a particular endpoint, particular digital endpoint, is a person. So first, I want to make it super clear that I'm not talking about identity. Identity is one thing. It's an important thing in many sort of respects, but this is not about working out who a particular endpoint is in the real world, whatever. It's rather being able to tell the difference, essentially, between a device and a device currently being operated by a human. Now, there's a sort of additional bit onto that, which is that if it's currently being operated by a human, can we give that human some sort of pseudonym so that we can recognize in this specific context if that human uses the device to interact with us at a later stage? And this has become an ever important part of these kinds of digital systems, decentralized Web3 digital systems, as we have, systems in general, as we have moved from being humans that largely interact with each other, as we were when I was born, right? In the 80s, this is what you did. You just interacted with each other. In the 90s, we started interacting with services via phones. Yeah, this was like a big deal. We had like telephone banking. And this, for us, this kind of meant that we started interacting with systems that were not fronted by humans, because the telephone banking things, although initially they were just call centers with tons of humans, and we were kind of interacting with a human over the telephone line, these eventually mutated into automated voice systems that we have these days. With the advent of the internet, of course, it became ever more divorced, and we sort of ceased interacting when with humans for many services, day-to-day services. And of course, with like Web 2, commerce, and so forth, it's ever more in that direction. Web 3 really just cements it, right? In Web 3, you never interact with a human. The whole point of Web 3 is that you can interact with a machine. Indeed, machines can interact with machines. So what's the point? Well, it's a foundational element of any real society. It's at the heart of many of our social systems. Commerce, everything to do with kind of governance, polling, voting, opinion, consolidation. Justice is based heavily on the ability to be Sybil resistant. Community building. Many elements of things that we take for granted from enterprise are actually based on Sybil resistant assumptions. Fair and reasonable usage. Noise limitation and general community management is also based on Sybil resistance. There's a lot of stuff that's based on knowing whether something is a human. If you want to if someone is behaving badly, then we kind of have we may want to bar them from the community for a period. And you see this both in digital services and, of course, in the real world. Yeah. Through Sybil resistance, we can introduce things like behavior disincentivization without having to erect barriers to entry, without having to throw away accessibility. For example, there are two basic ways of incentivizing behavior. Like, one of them is basically the carrot and the stick, right? And the stick is essentially give us a deposit and we'll take it away from you if you behave badly, right? Staking, if you like. It would be a very simple example. The carrot is we'll assume that you're going to be good and then do something to basically remove some rights, essentially, if you are not good. Yeah, this is what most civil society is based on. But you can't really do that in a blockchain if you don't have Sybil resistance. It works in civil society because once someone goes to prison, they can't recommit the crime again, at least not while they're in prison. It's like freedom is something that you're born with, and in principle, the government can take it away. Now, I'm not sort of talking about locking anyone up on chain, but at the moment, this course of action is impossible. And what that means is that we can't, it's very difficult to give away free things, to disincentivize behavior rather than merely incentivize behavior. Commerce and promotion very heavily relies on the ability to determine whether a transactor is a person. Here's a snapshot from a website that I occasionally use. This is a very nice whiskey, and it turns out that lots of people like it and all want to buy it. It's actually very difficult to get hold of in its native country. It's actually slightly cheaper to get hold of in Europe, but it turns out that part of, I suppose, how they make it a bit cheaper is that they limit how many an individual can buy. Very basic concept in regular commerce, basically very difficult to enact on a sort of true Web3 system. Community building, airdrops, right? Recognition and distribution of individuals within communities, very difficult. Airdrops are incredibly, broadly speaking, incredibly inefficient in terms of the capital expenditure. Because the whole point of an airdrop is that you want to give as much to as many as possible. And the way of doing that efficiently is to identify individuals and then give the same amount to each one. But if all you have is wallet balances, you're kind of stuck. And the distribution curve ends up being very hockey stick-like. And you end up not incentivizing most of the people very much at all. Fair and reasonable use. I mean, it's less of an issue now because if you use too much internet, they basically just throttle you, slow you down. You still get to use, you still have some internet. But back in the old days, 10, 15 years ago, if you use too much internet, they would decide, actually, you're probably just not using it fairly. It's not a reasonable use of this unlimited internet. And so they would basically stop you altogether. There wasn't quite as much possibility to just slow you down. Nonetheless, it allowed internet providers to provide near unlimited internet for almost everyone, by being able to distinguish between who the users were. 95% of people's usage could be covered under a flat rate contract. Freemium models, the bedrock of Web 2, are also heavily based on the ability to de-Sybil. It used to be the case that you didn't really need to de-Sybil, rewind, 20 years. These days, It very much is. If you want to open an account, then they usually have, like, I don't know, 3+ mechanisms to try to recognize whether you're truly an individual that they haven't seen before. Getting an Apple account without buying an iPhone, if you've ever tried this, it's like trying to run the gauntlet or something. These guys essentially refuse to give you an account. Of course, they advertise that you can get one for free, but I don't know what their AI is saying behind the scenes, but I've tried, I don't know, 10 times to get one. In the end, it's just, I have to buy the iPhone. Oracleization, I have a strong suspicion, will be made substantially easier with the ability to recognize individuals in a strong way. A very simple example of how society uses a Sybil-resistant kind of proof of personhood to manage oracleization is the jury system, right? Given some evidence, we would like some oracle to tell us whether a person is guilty or innocent of some crime. And how does the justice system oracleize that? Well, it basically selects an odd number of people at random from society and says, well, listen and give us your verdict. Similarly, in a similar sphere of life, representation and opinion gathering. Representation is an important element of society, and we manage representation through a Sybil-resistant means. Now, of course, due to not so great civil infrastructure, this is handled oftentimes less than ideally. In particular, representation is often confuses individuality with identity. Oftentimes, when you want to vote, you actually have to prove your real-world identity. Take your driver's license or passport, for example. But in principle, this need not be the case, right? Representation is about having a fair part of the vote, not about attributing that vote to your name. So how is it done? Well, in Web 2 and kind of before Web 2, there are a bunch of ways of doing it. And oftentimes in Web 2 these days, they're actually combined. So, for example, if you want to make a new Google account, you probably have to put a captcha and go through email and SMS verification. Sometimes SMS, it can be interchanged for the speak to a person verification. If you've ever had your Amazon account locked, you'll know what I mean here. It's basically this mad catch-22 Hall of Mirrors game until eventually you work out the precise button clicks and phone options to get you with an audience of an actual human being. Also, for slightly harder Sybil resistance, we might use things like social security numbers, credit cards. So if we move more into the world of Web3, in my research, I found nothing that has really appealed to me as a perfect solution. There are quite a few contenders out there, and they vary in three at least ways, like whether they're centralized or not, whether they're private or not, and whether they're really resilient or not. And resilient is becoming an increasing problem. Many of the systems have one of two issues with them. Actually, most of them have both issues with them. One I'm calling common confessional. And this is basically where you give up your privacy to a particular authority. Yeah? And that authority knows something about you that no one else, or that you don't particularly want shared. An example would be like your passport, right? So you might scan your passport in and hand it to some authority. And then that authority would be the authority that looks at everybody's passport. And so they would be in a position of power because they have all of this information. Yeah? Common confessional systems are not, I repeat, not viable for Web3. Another pitfall that you sometimes see Web3-esque individuality systems pushing or reliant upon are common key-keeping authorities. These are related to common confessionals. Oftentimes they come paired up. But a common key keeper is basically where there is an authority and they alone get to dictate through their keys who is an individual. Sometimes they even keep the key for you, but oftentimes they merely retain the right to dictate who is an authority, who is a person and who is not. Common key-keeping authorities are not a means of developing a Web3 individuality system. There's a few other things that I shouldn't really have to say, but I will anyway, because just to make it super clear. Putting something on chain doesn't make it Web3, right? There are plenty of Web2 strategies or Web2 centralized, authority-based strategies that can be trivially moved on chain, but moving it on chain doesn't change the strategy, right? It just means that it'll be executed, probably more resiliently. But the strategy itself is still not Web3. Just because it's a big long hexadecimal string does not make a pseudonym necessarily private. Yeah, it's still possible to link large unreadable strings to real-world IDs unless you take specific actions to avoid it. If there is a common confessional, it is not a privacy solution. We've seen enough data breaches over the months and years to surely understand that data is not safe if it is merely behind a corporate firewall or inside some trusted hardware. And what an individuality solution that is good for Web3 needs is not local individuality, local community membership, but rather universal individuality. They're two very different things. So there's a few examples of systems. It's not all of them. There are a lot, and I don't want to have to go into everyone. WorldCoin, which you've probably heard of, blockchain network, essentially trying to solve this problem, but doing so with trusted hardware from a single hardware issuer with a common key-keeping authority, opaque data sources, and common confessional. So not very Web3. Gitcoin Passport, quite widely used in the Ethereum community. More of an umbrella for other identity and individuality solutions. Common key-keeping authority. They issue who they believe is an individual. Using federated, but if you actually look at the data sources, oftentimes centralized, authority-based. And some of the more powerful data sources with which you can attribute an individuality score are things like Coinbase. IDENA, another one, also native, has a native chain. This is, of the ones that I've seen, probably the most interesting, actually Web3 solution with no common key-keeping authority, no privacy, no significant privacy issues. That said, it's a single mechanic, and it's not clear that this mechanic is going to be particularly resilient in the face of the ever-marching AI industry. So far, it's it seems to be okay. That said, so far it's got relatively little traction. I think just over 1,000 users. Overall, none seem to have actually nailed the problem. Now, there's two ways of thinking about individuality: remote and local. Personhood is not something that machines natively understand. We're not going to see a cryptographic primitive that suddenly solves individuality. Now, you can sort of say, well, there are things that make humans individual, like fingerprints, biometrics, and machines can measure these. And it's like, yeah, but then you end up with, there's nothing provable about that a purely digital system can comprehend. The closest that we're probably going to get in utilizing biometrics is probably WorldCoin. And it's really just a machine that attests in a not trivially breakable fashion. So we have to understand that individuality is about attestation. It's about elements within a digital system attesting that other elements in the digital system are individuals. And the question is, what's the basis for this attestation? Is it physical proximity, or is it some other suspicion? Do we believe this account is an individual because we have met the individual and we don't believe they have met anyone else at the time that we met them, and therefore it's likely that this individual is is unique within some particular set? Or is it kind of just that we've seen something on a screen or we have some other evidence that they're an individual? And this can be used to basically segregate methodologies. When we talk about remote attestation, basically non-physical, non-direct evidence-based attestation, AI kind of becomes a bit of an issue, yeah? And the problem is, of course, that if we're talking about direct physical evidence, then practicality can become a bit of an issue. So we're kind of stuck between these two constraints. Nonetheless, I think with enough innovation, with enough imagination, we can come up with some very viable solutions. So what do we need? What's the game plan here? Well, what I believe will make Polkadot quite a lot more useful in the real world, beyond kind of DeFi and NFTs and virtual blockchain stuff, is a way of trivially recognizing an individual. Not identifying the individual, not saying, I know that this is Gavin Wood, but rather recognizing that this is one person, one unique person. I don't think it's going to be a single-shot solution, which means it's crucial to make a framework that's modular and extensible so that, firstly, existing solutions that are not unreasonable, like, for example, IDENA, can be integrated. And secondly, that it's one individual's imagination of how, what mechanisms might be viable does not limit the system. Yeah? This should be, in some sense, open to everybody to contribute solutions. Secondly, we need strong contextual pseudonymity. I actually originally had written anonymity, And in some sense, I do mean anonymity. It's an anonymity from your, let's say, real world identity. But nonetheless, we also want pseudonymity so that within any particular context, you can demonstrate that not only are you unique, but that if you go back to use the system in that context, that you are the same unique person from before. And crucially, we need SDKs, APIs that make this a utility as easy to use as any other first-class citizen in the Substrate or Polkadot smart contract, or when it comes, the Jam ecosystem. It must be easy to use. In, let's say, more specific terms, I don't know how many frame coders there are out here, but one of the lines that you'll see a lot in frame coding, so when you're writing new blockchains, will be this let account equal ensure signed origin. Basically, all it's doing is taking the origin of a transaction and saying, right, is this origin, did it come from an account? And if it came from an account, most of them do, if it came from an account, tell me what account it came from. But an account is not a person. A person may use one or more accounts, but also a script may use one or more accounts. Accounts don't give you any information on individuality, at least not alone. So, if we want to ensure that a particular transaction is coming from a person rather than merely an account, then we would like to be able to switch out this line for a different line. Let alias equal ensure person origin with some context. And the nice thing about this, okay, there's two nice things. First thing is, we're not just asking whether this is an account that's signed the transaction, we're asking whether it's a person that has signed the transaction, okay? That in and of itself is a huge leap, a material difference in what we're able to do. The second thing that is also very important is that, well, different things will have different contexts, and we have anonymity within the context. We actually have pseudonymity within the context, right? So this my context and the alias are linked. When the context changes, the alias changes. And aliases of different contexts are not linkable, nor is the alias with the underlying person. They're all totally anonymous pseudonyms, yeah? And this becomes a very important toolkit, I believe, in blockchain development, and particularly development of real-world useful systems. So what mechanisms might we, what restrictions might we place on the mechanisms for actually recognizing an individual? Well, firstly, it has to be generally accessible, yeah? If it only allows a subset of society to join, then it's not going to be very useful. It shouldn't require assets. It shouldn't require expense, at least not unreasonable expense. Inevitably, there will be trade-offs between different mechanisms. I don't believe there's a silver bullet mechanism. But there are some things that can be traded off and some things that cannot. Resilience, centralization, authority should not be traded off, right? But there may be some mechanisms that require less effort, but more commitment. And other things which require more commitment, less commitment, but more effort. There should be a reasonable expectation that a proven person, a person that's gone through the system, an account, if you like, that is linked to a person, or an alias, is backed by a unique, real-world individual. Now, different mechanisms which sort of measure individuality in a decentralized Web3, resilient, non-authority-based way are probably going to overlap, which means realistically, we're not going to get it perfect on this. But it shouldn't be, it should not be an order of magnitude out. Yeah? It should be substantially less than an order of magnitude. Furthermore, there should be extremely strong resistance against identity farming. So organizations of a few people who really want orders of magnitude more personhood identities. This it's crucial that it safeguards against. It might be that some mechanisms are capable of offering up a sort of lower confidence than a person score, right? This is more like a stretch goal. Some mechanisms may do it, some may not. Some may just like be binary. Either we believe this account is a unique individual or we do not. Others might say we're 50% sure. But it might be that the individual has two accounts that we're both 50% sure of. Of course, it must be permissionless, and of course, it must not be difficult. And I shouldn't need to say it, but no common confessionals, no common key-keeping authorities. Okay, so why? What's the payoff? Well, discuss some of the ways how society uses or relies, indeed, upon individuality. But how does it translate on-chain? Well, we can start imagining Polkadot where reasonable usage is free. No transaction fees, right? If we imagine a plaza, if you're not familiar, this is basically Asset Hub ++, Asset Hub with smart contract functionality and ability to utilize the staking system. If we imagine Plaza, we could, with this kind of infrastructure, we could imagine a plaza where you don't need to pay for gas. Gas is free as long as you're in reasonable usage. Of course, if you're writing scripts, doing lots of transactions, you would need to pay because you wouldn't fit all under a single person's sort of usage rights. But we can imagine these systems starting to be free for people to use. You can imagine per-person airdrops, really efficient community bootstrapping. We can imagine much more progressive ways of managing Polkadot's governance. Now, I'm not especially convinced on the one person, one vote mantra. I think it's necessary under some situations for legitimacy, but it doesn't necessarily give especially great outcomes in general. But we might look into things like quadratic voting. We might look into things like territory voting. And for certain elements of representation, one person, one vote can be very illuminating. We could imagine an oracle system not entirely unlike a jury, a real-world jury, where parachains and smart contracts could say, well, we have our sort of local, lesser staked oracleization system, maybe doing price feeds, maybe doing stuff like when users get upset at other users, there's some sort of dispute, maybe resolving disputes. But then they could also say, well, we will also utilize, if necessary, a kind of grand jury, right? A kind of supreme court, which is convened from known random individuals to make decisions, who would get some sort of, presumably, little payment for their help in resolving such a dispute. And we would, because it's drawn from a large set of unbiased, we would broadly presume individuals, we would expect it to be a resilient and reliable way of resolving such disputes. You can imagine noise limitation systems, particularly social media integration, decentralized social media integration, which could help manage spamming and bad behavior. And we can imagine in DeFi, perhaps, reputation confinement systems, not entirely unsimilar to some sort of, credit score, but perhaps more with a have you been sort of caught not paying things back score. Allowing systems to offer something much more like a freemium model. Good. So that is the first part of the talk. I hope it was interesting. I've got an extra little bit that I'm going to talk about now to just sort of go over the other thing that I've been working on, Jam, for those of you that are not super familiar with it. There's a few QR codes there in case you want to read more about it. But basically, what is Jam? Well, Jam is Jam takes Polkadot, utilizes a lot of Polkadot's technology in order to deliver what Ethereum folks would say is a roll-up host chain together with a roll-up reactor. I actually call it a cynical roll-up, a new type of roll-up, not an optimistic roll-up, not a ZK roll-up, but a cynical roll-up. And it is, if you want to read more about what I mean by cynical roll-ups, there's a look at the top right QR code. One of the key advantages with Jam over Polkadot, and indeed other proposed scalable systems, is that it does not persistently shard state. State is retained on-chain, small amount, but also in a secure, decentralized data availability system. Indeed, a lot of data is retained in there, 1.6 petabytes by our estimations. Now, this isn't as coherent as data that remains in the core, in the middle of the chain, but it's still mostly coherent. And what does this mean? Well, it means that we've found a way to scale without breaking resilience and without giving up too much coherency. And one of the issues on Polkadot is coherency. A smart contract in one parachain, as a smart contract in one parachain, it's not so easy to compose one's utility with a smart contract in some other parachain. The interoperability is there via XCM, but it's inconvenient. And this inconvenience restricts, practically speaking, the levels of composability and of composable utilities that can be produced. Jam eases this constraint substantially. And as it happens, by moving from WebAssembly to a new technology, PolkaVM, it's also able to offer substantially increased performance. And there are a few other tricks that we do to get this substantially increased performance. But with the increased performance, we're able to, we project, all right, so treat this number with a pinch of salt, but we project around 1 trillion EVM gas a second throughput. Now, it's EVM equivalent, and a lot of this throughput is in large part because EVM is very inefficient when it's mapped onto real-world hardware, whereas PVM is eminently able to be mapped to real-world hardware. Jam is permissionless and unsequenced, much in the same way as the Polkadot relay chain. It doesn't care about what order parachain transactions arrive in. it's up to the parachain collators for that. And Jam is parachains compatible. It's Polkadot 1 compatible. I think they're calling it Polkadot 2 now, so Polkadot 2 compatible. And it's Ethereum bridged in much the same way as Polkadot is today. Head to the grey paper for more information. And I'll mention one more thing, because I think it hasn't really been mentioned in a very straightforward and upfront public way yet. There is a lot of DOT ready to be handed out to coders. 10 to the 7 DOT, right? That's 10 million. It's quite a lot of money. There's also some KSM. We're looking for coders who like exotic languages and like to get some crypto for coding stuff in an exotic language. You can kind of choose what language you want. There's some mad stuff here. OCaml, Scala, Smalltalk. So this is an effort to make Polkadot more resilient. An ecosystem with a single core development team operating on a single code base. I mean, it's done as okay so far, but it's not ideal by a long shot, especially for long-term resilience. So we need to do better, and this is a significant effort by the Web3 Foundation in incentivizing the creation of a better situation. 500,000 DOT is ready to be handed out to teams that can create a full production-ready Jam implementation by the time that Jam launches. You can choose your own language. We've put the languages into sets in order that we don't get 50 Rust implementations. Yeah? So each set has a quarter of the prize fund, essentially allowing for 5 teams from each set. But we don't mind so much, or we're happy to sort of forgive teams that happen to land upon the same language. It's just that if more than 5 teams happen to land upon the same language, or indeed in the same language set, then they'll be sharing that part of the prize pot. 5 milestones. Each milestone, 100,000. First milestone is this importer milestone. Actually relatively straightforward, just has to pass block execution conformance tests. Has to be able to import a block, the basis of any blockchain. Milestone 2 has to basically implement all the off-chain stuff. Be able to produce blocks, do networking, join a test net. Milestone 3 has to pass all of the conformance tests, including finality, Polkadot, this Polka VM, and also pass lesser performance tests. Has to go at a fast enough speed to work on Kusama, basically. And milestone 4, full speed node, has to go fast enough to work on the Polkadot mainnet. Milestone 5, finally, it has to be audited and good to go as a production-ready node. Now, for teams, it's not just about the prize, although I think the prize should be a significant incentive. There's a bunch of other things that I hope and hopefully would like. I think actually we have decided now to do. I think it's past the fellowship vote. So fellowship sponsoring, what do I mean by this? Essentially, you get to join the fellowship. You get a free pass into the fellowship when you create a jam implementation. Now, what does entrance into the fellowship give you as a fellow? Well, it gives you voting rights on protocol decisions, and it gives you a salary. A real-world USDT fiat salary. In addition, professional audits. You don't have to pay for your own auditing. We've got that covered. International seminars. We want to make sure you're well educated on the jam protocol. Travel expenses. Hardware expenses. Servers. And access to the jam toaster, a mini supercomputer that can simulate the whole jam network and help you optimize your code. You don't have to write literally everything. There are a few exceptions. You don't need to write the cryptography. You can pull that in. And as for networking stack, that's also exempt. You don't have to rewrite quick, which happens to be our networking layer. Good. That's what I came to say. So thanks for your attention, and enjoy the rest of the conference.